Welcome to Insight Builder channel and another interesting video on embed your data for free, open source embedding models, deep dive into concepts and code. This particular video I believe will be very important for anybody who is trying to work with large language models or with any of the text or natural language processing related applications in production. Why? Because embedding is one of the key activities that you have to do in order for getting your production up and running. So what I am trying to say is any of the data that you're having has to be embedded for it to work efficiently with the open source models. This open source embedding models are called sentence transformers. It has been developed by Niels and Irina, and a huge shout out to them. And this particular paper, Arxiv paper, is already available for you guys to take a look at it. This particular presentation will be shared over the GitHub repo. So any of the details you can get it from the github.com Insight Builder. Okay. Now, what is embedding? So what is the key step or key idea of embedding? Idea is very simple. You take any of the text, like for an example, a word like good or a sentence like this is nice. You send it to sentence transformer model, and out comes the series of numbers. So it is called as vectors. And depending on the number of words in the sentence, the series, the vectors will be different. Also, depending on the sentence transformers model, the number of vectors, the elements in the vectors will be also different. All these are the key aspects of a sentence transformer model. So you given a English sentence or in fact any language sentence. Currently there are models available for more than 50 plus languages which can be embedded into these vectors, and each of the model will be different. So it will not be the same model, it will be different. So we will be diving deep into this step by step. The point of embedding, there should be some reason, right? Why will you convert the sentence, the English or any of your language sentence to numbers? You'll have to use it somewhere, and the usage, these are the list of usage that you can do. Like you can check how similar are these sentences. You can use it for searching. You can use it for re-ranking, retraining and re-rank. I will be going through these process step by step because there are some of the important details and some of the applications that I will be discussing that will actually give you a better insight on how to use the embedding. Okay, so before I dive into all this clustering, paraphrase mining, etc., you guys might be actually new to all of this idea of large language models, idea of artificial intelligence and all those matrices, etc. I would suggest that take a look at this series. I mean, when I am making this video, these series are at the top of the playlist. Take a look at that in my channel, Insight Builder channel. You will get a good idea of what is going on behind the scenes when for an example, when ChatGPT is generating the text, or when you are trying to give, when you are chatting with the chatbot that is powered by OpenAI's chatbot. So at the back end, the process, so the backend, what happens is the model takes in your question or your query or your chat session, and it converts it to series of numbers, and then it sends it to the model that is the OpenAI's large language model, and then it gets you the text output. But the point here is the communication between you and the model is through these numbers. It's not through this words, even though it might seem so real that it feels as if you are communicating to the machine with regular language. In fact, it's not. So this is what I discuss in detail about in most of the videos that I am sharing here. This is what I go in detail about this step by step. I also try to, so especially in these videos and even on working on Samantha model on modal. So I discuss these ideas from the backside, what exactly happens in the model level. So you guys can get a clarity on when you are going to make a product around it. So that's more important, right? With that said, let us go to the PDF and continue our discussion. So we were discussing on the usage, right? In case of usage, I was talking about similarity, semantic search, clustering, paraphrase mining, translated sentence mining, cross encoders. So all this, even image search, all these things can be done when you have these numbers. How is that even possible? So let us go down the rabbit hole, right? So usage concepts, how embeddings are used. So this is where all it starts. So you might have a lot of embeddings, that is, you might have a series of sentence that is already converted into this. I am only showing 3 columns here, but depending on the number of sentences you have, number of words you have, this 3 columns might be 3000 columns also, or 30,000 columns also, and the query will be a single column, and you send this query and try to check the similarity. So how do you check the similarity? This is where this particular graph comes. All these pictures you see here has been taken from this particular website, which is the sentencebird.net. What I have done is, so in case of this particular website, they give a very good introduction about the sentence transformers, how to use it, what are the applications, and a lot more. So this website is quite in detail and in depth. What I have done is, I have just taken the important points from these websites and I have condensed it in such a way that it will be easier for you to grasp what is going on. So huge thanks to sbird.net for sharing these pictures, and you can actually get more details once you go there. Anyway, now getting back to the discussion that we are having, how to find that 2 sentences are similar. That is the first and foremost point you have to understand. And for this, we are going to use something very simple. Here you see this is y-axis and this is x-axis, and inside this x and y-axis there are lots of points. And you see in this location, one is in orange and another is in blue. All this blue are the text embedding that is already available. Assume for a moment that instead of having all these numbers, the embedding is having only 86 and 95, 57 and 82, 28 and 14. Rest of the numbers, assume that it's not there. So only these 2 numbers are there. Then this embedding can be placed inside this x and y graph. And the same way, when you are going to give the query embedding, also you can embed this query inside this graph based on the x and y position. When you position the embeddings like this along with the query, any of the document that comes close to the query is relevant document. This is what the sentence embedding team, the sbird.net, Irina and Niels had come up with, and that is what they have made it as the sentence transformers website, sentence transformers library itself. And sentence transformers library is kind of a supporting library. So the concept of the relevant document is clear right now. At least to a certain extent, you must have understood that what is, what is a query and how it is. When someone says that, okay, the query is placed in the vector space, what they mean to say is that this particular query, whichever English language query, so let us take an example. So this is nice. It's a query or a sentence that you give it to the model, and that will actually go and sit in this particular point. After that, it will check the algorithm inside the sentence transformers library, will check what are the other documents around it, and then it will return those documents. So that is called as similarity searching. Right now, you must be having this question. Kamal, you are telling that I will be giving one query and around that there will be multiple documents. So will I get any reply from the sentence transformers which is accurate? Actually, no. You will not get accurate results from sentence transformers or similarity search. You will get approximate results only. So you see the gap here. The relevant document is not exactly lying on top of the query. It is near to it. Basically, these whenever the numbers are converted, whenever the sentence is converted into numbers, the numbers are converted in such a way that it holds the meaning, the semantic. The semantics means the meaning of the sentence. The numbers hold the meaning in the way of statistics, in the way of the machine learning algorithms. It holds the meaning internally, and that is how the document is. This relevant document is positioned here. For an example, if this relevant document is, for an example, instead of the document being this is nice, if the document is going to be semantic searches done by position query in vector space. So if this is going to be the document, then probably it will be somewhere here. Okay, why am I telling this? How will I know all these things? Basically, all this, the numbers that you see here, it has been created or trained by giving the sentences as a training data set. So I'll be giving you a brief on how it is being done also, so that you guys can understand what is going on. When it comes to this particular explanation that I was giving, that the relevant document and the query has to be nearby in order for the sentence transformers to identify it, and the similarity search algorithm to provide it to you, right? And that is done for one sentence. But what if I want to do it for all this sentence? So assume that I have a data, and inside the data set I have some 15 sentences, and I want to check whether the query is linked with all those 15 sentences. There are two ways. I can actually check all those 15 sentences one by one. Another way is I can chunk all those 15 sentences into a single sentence, and then I can check the similarity. So that is where the paraphrase mining comes. Whenever there is a huge amount of data, or the data is split into multiple parts, you can chunk the sentences, and then you can make it as a single data point, and then you can do the relevance, the similarity search on top of that. That is called as paraphrase mining. Semantic search is also done by positioning the query vector. So as I was telling, it is done by positioning. And also, the most important point is there are two kinds of semantic search. One is symmetric and another is asymmetric search. Whenever, for an example, if your embedding is all having a long sentence, and if your query is having a small sentence, then it is asymmetric, meaning the length of the embedded sentences are greater than the length of the query sentence. Then it is asymmetric. If it is same, if the sentence lengths are same, then it is symmetric search. Why there are two types of search? Because symmetric and asymmetric search will need different kinds of models and different kinds of training. That's why there are two different methods. And most of the time, current models have developed to such an extent that the asymmetric model and symmetric models are not having that much amount of a difference. But in the past, yes, it was having. There is a strategy called as retrieve and re-rank. It is one of the another strategy when you are having a lot of data. So what happens is, when you have a lot of data, you send in a search query, and this query will retrieve a lot of information. Because if you assume that you are sending one query to 30,000 data corpus, and you will be getting some thousands of data out telling that these all sentences are similar to your query. Then what happens is, there is something called as cross encoder. So all the sentences are sent into the cross encoder along with this search query. So each sentence, so thousands of sentences that you get from the document collection using retriever, is sent along with the query sentence. So both are sent together into the BERT model, and it is classified. So the cross encoder does only one thing. It says whether both the sentences are similar or not. It does not compute the embedding. Again, I am repeating, cross encoder does not compute the embedding. So it does not try to place the sentences on the top of this kinds of a graph and try to find the similarity or the distance. It is programmed in such a way, or modeled in such a way, that the entire data, the entire sentence is either near to or either similar to sentence B or not. It is either 0 or 1. Yeah, there will be 0.1, 0.2, 0.3 to show a range. However, the final output is, okay, it is similar or not similar. That is what it's going to do. And when you are going to use the retrieval and re-rank option, you will have thousands of sentences coming from the document DB, that is your database. And when you attach it to a cross encoder, you will be able to reduce that number of thousands of documents to smaller number, because it will classify whether those sentences are similar to your question, and then you will get a better search result. So that is called as retrieve and re-rank. When it comes to the last step, this is one of the interesting aspect called as topic modeling. You must have already come across these kinds of algorithms called as k-means clustering and clustering algorithms in machine learning. In case of the sentence transformers and the neural networks also, you can do the same thing. How are you going to do that? instead of actually looking at the points as a separate entities or sentences as separate entities, once you place them on this kind of X and Y graph, you can actually see the clusters. So here I have arbitrarily placed 3 circles, and these 3 circles are encircling a couple of points, and these circles can actually mean a particular topic. So red circle can mean a topic 1, green topic 2, and black topic 3. In this way, what will happen is you can create a kind of a internal segregation within your corpus. This is kind of an unsupervised learning that you can do once you do the embedding. So now you understand, by converting the sentences, the raw sentences, into numbers, you can do a lot of things just by using numbers. And also one more important thing, the distance between this relevant document and the query can be found in multiple different ways. So this distance is called as cosine distance. It is called as sometimes you can use Hamming distance, you can use Jacquard distance. So there are various kinds of distance formulas that is being used. The beauty is, as a user, as an application developer or a product developer, you don't need to really worry about the algorithm. It is already incorporated into libraries like sentence transformers, and all you need to know is one of the methods that you need to use for getting the relevance documents. So the point here is to understand the concept, what exactly you want to do. After that, getting the things done can be done using the various methods and classes available inside the sentence transformers library. This is one of the key aspects I always talk about when it comes to my discussions. I believe you will find some interesting information in this video. So do leave a like and share it with others, and subscribe to my channel for further updates. The point I wanted to reiterate here is open source libraries are abundant these days. To understand these open source libraries, you have to first of all understand what kind of problems they solve. So the point of sentence transformer library is that it is solving a problem of finding similar sentences. If you ask me in a single sentence, then that is a challenge that is solved by these sentence transformers models. And the library, sentence transformer library on the whole, is kind of a open source library that helps you to interface the data and your application requirement with the model. So that is the trio of help the sentence transformer library is doing. I believe that you understood a brief about this. If not, just do a rewind of 5 to 10 minutes rewind, and you will be able to understand this part very easily. Let me go to the next step. Further going down into the rabbit hole. As I was explaining all this similarity sentence, so distance metrics is used for finding the similar sentence, paraphrase mining, semantic search, re-ranking, all these activities I had explained in the previous slide. I have written it for your reference. The most important application that I did not cover in the previous slide is image to text. The same way you can convert the text to these numbers, you can convert the images to the numbers. If you are from the computer science background, or if you have already taken any of the courses in computer science or programming, you will be already aware that that our files and the images are already stored in our computer hard disk as numbers. The difference when it comes to the numbers that is stored in our hard disk and the numbers that I'm talking about is the relation or the link. What happens is when I'm going to embed this particular picture, the picture of dogs on snowy forest, is what happens is it is not just there to store the image. It is there to semantically, it understands each of the pixel, and it then decides, okay, this particular pixel is representing part of a leaf. This particular pixel is representing part of a dog. So like that pixel is able to learn, which is not the case if you are going to think about the numbers that is already available in your hard disk. So this is the key difference that you guys have to keep it in your mind. Everywhere there is numbers inside the computer. Even this particular slide that you are watching, even the video that you are watching in YouTube, it is all streamed as numbers. But the only difference is these numbers are there to stream the data to you, but not to tell what the data contains. But these numbers that is getting created using the embedding will tell you what is there behind the numbers. And how it is being done, It is done with the help of the models. So you see there are lots of different models available. Let us go to the browser for a moment, and let us actually take a detour. If you go down in the Embed website, you can see there is something called as pre-trained models. All these are already pre-trained for certain kind of sentences, certain kinds of data sets, and their performance have been already ascertained. And a lot of teams have been involved in this. And if you see, when it comes to the name, the name has a significance. When you say all MPNet base v2, here you can see the significance of the parts of this model name. So all model means it has been trained on all the available training data, that is almost 1 billion training pairs, and designed as a general purpose model. And it provides one of the best quality of embedding available out there. What this means is that any kind of sentence you provide to this all MPNet base v2, you will get a quality embedding, meaning you can use the embedding, the numbers that is provided by this, and you can do a lot of applications using that model. And this model size is 420 MB. It's not that huge, but it's not that small also. If you are going to use this model in your application, you or in your particular product, then you need to have a way to use this model. I mean, load this model into a Python object, and then you need to send the query or send your data to it and do the embedding. So how do you do that? That is a very simple option. All you need to do is import sentence transformers class. Here you see this class, and then you need to call the model name. After this, you can send the text sentence to this, and you will get the output as vectors. It is as simple as that. You will see some of the examples provided here. So once you create the model, you have to call model.encode. This model.encode method will encode this particular sentence, and it will start giving you the output in vectors. And after that, you can start doing various kinds of scoring or similarity searching, like dot score, cosine value, etc., and you can get a lot of information. In this particular discussion, I have not actually given any kind of code for you guys. You might be thinking, Kamal, you always talk about practicing. So this time it is going to be a little more different. The idea of me providing code has been a constant, so I wanted to change it. So what I want you guys to do is I want to tell you how I actually do the coding, or how I get the examples. So I visit the documentation pages like this, and I start understanding the subject, and then I take the examples directly and take it to a Colab notebook or Jupyter notebook and try to execute it. Once I execute it, it will be having the same example sentence, right? This is where I start changing. So I either start changing the sentence, I add additional sentence, I make it smaller, I try to kind of change the overall example in certain ways so that I can learn more about it. You might have a question that, Kamal, I see that this particular encoding is happening for a list. What will happen if I give it as a dictionary? What will happen if I give it as a JSON object? How it will work? These kinds of questions is what I ask. And then I try to send that kind of a data set or data structure into the encode method and see how it works. When I start doing these experiments, I'll start learning more about this particular method. And you might be thinking, Kamal, you can do this by looking at the documentation. But the most important point is that when you know exactly what is happening, I mean, you have actually tried it, right? You have tried changing the data structure from list to dictionary to JSON object. And you might be thinking, what is the difference between a JSON object and a dictionary? Find it out. So all these things will be a very good way of practicing. After that, you can think about this util function. This util module. This util module is part of sentence transformers library, which contains various measurement methods. That is similar distance calculation methods. It's not just one. Dot score is only one method that is shown here, but there are other methods also available. So take a look at that. Do some research around that. You'll be able to find all the information here. So if you go to the util page, you'll be able to get all the information about the methods, how to use it, what are the examples. So you see all the dot score, cosine similarity, the community detection, all these are explained in detail, and you can actually practice it right there. Now coming back to the models, Just give me a moment. Coming back to the pre-trained models, the idea that I was trying to share here is that the models are already available, and these models are already performance tested for you, and you can directly use it. There is nothing stopping you. But then you might be confused. Kamal, there is so many models. How to choose? The easiest route is to choose the best model. That is, go for all MPNet base v2. So this is one of the standard model that whenever anyone is new to sentence transformer is allowed, advised to choose. So go ahead and choose that. But then don't stop there. Try to see how, take your data, your corpus of data which you're going to follow is going to be same. Try to work with multiple different models and see how the query returns. So you need to know how to test for your requirement. Probably when you are giving the data that is specific to your application, the models may not work as the way it is shown here. Maybe the all distill robota v1 performs better than all MPNet. Then it's better that you go with all distill robota. No one is going to stop you, or no one is going to say it is wrong. Only thing is that you should have the data with you, and that is how you can select the model. In order to confuse you a little more, let me go to one more leaderboard. So this is one of the main leaderboards that is available in Hugging Face Hub. So this Hugging Face Hub gives a very different set of models here, and this set of models is also, just a minute, let me refresh the page so that you guys can see it better. This model actually gives a overall model ranking, and just give me a moment. Okay, so let it load. It is taking a bit of a time. So we had a small digression where I had shown you how to look at the models and how to work with the examples that is already available in Embed.net. I'll be anyway, I will think of sharing a couple of example code along with this particular YouTube description, so that it will be easier for you guys. But still, I would prefer that at least for this is one of the most important application, and I want you guys to dive deep into the embedding process and then understand it step by step, because there are lots of models available, and each of these models have different kinds of impact on the final output that you're going to have. Moreover, on top of this, these are all open source models, right? There is closed source models also. So before we go into these slides, let me show you these. So model ranking similarity is already there. I already showed you. So there are various rankings available. So when you are only going to do sentence similarity, then Microsoft MPNet base will be better. Okay, and when you come and look at the text generation, or when you are looking for the comparison between open source and closed source and text generation kind of a setup, then E5 large v2 is having a sequence length of 1024, and it is at the top in the leaderboard right now. And following that, it is instructor excel and instructor large. All these models are open source, and you see their sequence length is 768 and 1024. What is this sequence length? Basically, sequence length is the maximum length of the sentence that the embedding function can embed without truncating. Meaning, if the sentence is longer than 768 tokens, or in words, it will be across 650 words to 700 words. If it is more than that number of words, then it will be truncated. So above that, it will not be embedded by the model. It will be discarded. You have to be aware of these limitations also. When you are working along with these limitations, basically the text that you are sending in should be split in such a way that it can fit into the model input. It is as simple as that. You don't need to think that, okay, rest of the data, what will I do? It's very simple. You just cut the text that is longer and make it as one more extra data point. And when you are going to do the sentence similarity, you can use the re-ranking. I was talking about the re-ranking, right? This particular method. So you take this document collection, you will get some hundreds or 200 similar sentences. Then you do the cross encoder and you will get the similarity out. So there are ways around these limitations also. What I wanted to show is that what is at the top and how to decide which model to use. And why I have kept it at the last, I will come to that at the last. Let us go further. Till now I was talking about sending your text data into the embedding and trying to get the numbers, but and also I was telling about choosing the model. I was showing how to choose the model from the website, looking at the leaderboard. But what if everything fails? What if you are not getting a good result? Does it mean the sentence transformer application or the library and the model is useless? Actually, no. The sentence transformers library, the open source models are trained on certain kind of openly available data. But your data may not actually match with the openly available data. Because of that, the performance of these models might be subpar. In order to improve the models, the best option is to fine tune these embedding models. And in order to fine tune these embedding models, it is a little bit different in case of fine tuning the neural network model. This is also a neural network only, but the output that you are expecting from this model is just numbers. So how are you going to fine tune it? So basically what we do is we try to compare the similarity distances. That is one of the strategies. There are lots of strategies. One of the strategies that has been shared by the sbert.net is to decide on the sentence length. First and foremost, you have to decide on the sentence length. Then you have to decide on the architecture of the model. Most of the time, you don't need to create the architecture from the scratch. You can use the BERT or Roberta model as a start, and then you can build on top of it. And then the input examples. So this is where your data comes in. So you actually start giving input examples, and input examples should contain your data as well as your query. And you should know the similarity. What is the expected similarity of this? So for an example, if you are going to say, if you are going to give all these bulleted points as input data, and the query is going to be, these are the processes used for neural network. This is the query I'm going to give. Then all these sentences should match with maximum similarity. That is more than 0.9 for all these sentences. And if there is a query that give me the examples of sentence transformers application, then these data should be less than 0.1 or 0.2 when it comes to similarity. So like this, you can start giving the data into the sentence transformers, and then you can start fine-tuning the model. Once you start fine-tuning the model, then the output that comes out of that fine-tuned model will be much more better than what you get from the open source model. So that is called as custom embedding or training your own data. Especially this kind of training and fine-tuning requires lots of data. It's not just one or two sentences. It will require at least 10,000 to 20,000 sentences, and it will require lots of resources also. But think about you need to think about the time, the effort, the resources that you provide for fine-tuning as an investment or kind of a long-term benefit that you are going to get out of the model, because the model is going to be queried a lot of time, right? It's not going to be just once it's going to be used. So also you need to have that logic, that why are you going to fine tune a model. So for an example, if the model is able to give you a performance of 85%, and if you fine tune the model and if it is going to give you 86%, will you need to fine tune the model? If you ask me, no, you don't need to fine tune the model. You can actually survive with 85.5. The 0.5% improvement is not going to help you. But in case if it is going to give you 95% returns or 95% retrieval, then yes, fine tuning it is a good idea. These kinds of decisions will require prior experience and also expertise in deciding which data set, which kind of query, and also the input from the users. All these will be needed for you to do the fine tuning. So keep those things in your mind. I have just given you the overview here about training the model. I have not delved deep into the process of it. Probably if you have some comments, do leave a comment. Maybe I will look into that and I will try to provide some inputs. But this is the point you need to keep in mind when you are thinking about fine tuning. Now, we have all spoken about the models, we have spoken about the applications, the usage. Then comes this question. Kamal, you are telling these models will be of 420 to 500 MB. Just a minute. Let me go to the browser for a moment. So this has already got loaded. And let me go to the pre-trained model. So here you see the size of the model is 420 MB. And as I come down, you see there is something called as multi-QA mini LM, and this is only 80 MB. And the speed is 14,200 sentences. I mean, this is 4 to 5 times higher than the all-MP-Net. And if you go up here, it says that all-MP-Net model provides the best quality, while all mini LM V2 is 5 times faster and still offers good quality. So what is the difference between best quality and good quality? The difference is very simple. So if you come down here, if you see the multi-QA all MNLI L6, it is 68.06, and all MP-Net is 69.57. So it is almost 1.5% difference. And if you are going to work with the similarity search, and if you are going to work with approximate nearest neighbors, this 1.5% is not going to be a huge deterrent, and the benefit you are going to get is huge. And on top of it, let me go to the PDF. If you are going to use a retrieval mechanism, this retrieval and re-ranking, then you don't need to even worry about that 1.5% difference. You will be getting a huge benefit on the speed as well as the size. So how is this possible? So that is where the idea of model distillation comes into picture. The concept is very simple. So there is a very detailed teacher model. That particular model is designed with deep many neural network layers, and there is a student model which is a small model which is having lesser number of layers, but still once the teacher model teaches the student model by using the neural network training, then that student model is also able to give a very good result. So you see here the teacher model is giving 85.44 benchmark, but the student model, which is having only 8 layers, is giving a better performance. Yeah, after when the layers are reduced, the performance reduces, but even then it is more than 80%. So this is the one of the key points that we need to understand when it comes to model size and the model speed. Excuse me. So let us continue further. So in order to do this kinds of speed gain, reducing the model size, working with large corpus of data, there are a couple of ways you can reduce the dimensions of the vectors. Instead of using 768 points, you can use 512, or you can reduce it further. You can reduce the size of the numbers. So if you had watched my earlier videos, especially on quantization, if you visit this particular video, you will understand what is quantization. So it is basically a compression methodology, where instead of using float, if you use integer, then you will save a huge amount of memory. Also, you can reduce the number of layers. So the point here is, this is one of the ways where you can get better output at a lower memory and resource allocation. So this is one of the point I wanted to add, and this is a little bit advanced topic. You might have to study a bit further, but I felt it has to be introduced. I hope that you will do a little more deep dive on that model distillation. And coming to the model rankings again. When it comes to model rankings, the purpose is not just to boast that, okay, the model that I trained is good, or model that someone else trained is bad. That's not the intention. The intention of the model ranking is to show to the community, to the industry, that which model is best for which application, so that the community can start using those models for building the application. And it is one of the imperative that whenever you are taking the data from the open source, giving it back is also very important. So when you train on your data, or if that data is not that much private, if you can share the model, go ahead and share the model. Keeping the model open source community live with new models, new kinds of training algorithms, new kinds of training model ideas. That is going to have a huge impact as we progress in the artificial intelligence era. Here I have given some of the examples, and if you go back to the browser and if you go back to the MTB ranking, you will see that MTB ranking is not just only for open source models, it also includes the closed source also. Closed source models like, excuse me, closed source models like, just a minute. We have OpenAI's text embedding ADA is also there, part of it, and which is actually lower in the ranking when it comes to the various kinds of tasks, starting with classification, clustering, pair classification, re-ranking. All these tasks are done based on the embeddings created from these models, and then this particular leaderboard has been created. So if you create a new model, if you submit it to the leaderboard, the leaderboard will have a backend application or the test suite which will test your model based on all this activity, and then it will rank it. So you don't need to do anything as such. So all you need to do is submit the model. You will see that there are various applications that I was talking about. Each of the model is if, for an example, if you're going to use any of these applications, you can still come down here and you can check which model you want to use. So this is also a possibility. So do take a look whenever you are having some time. Let us go back to the PDF. So I believe that I have given you an overall picture about the sentence transformers, how the embedding is getting done, how the embedding is getting used, and what are the ways to reduce the model size, how to fine tune the model, how the models are ranked. So these are the key points, key questions that as a developer, as a business leader, or a application user, you must be having. So I believe you have learned a thing or two from this video. Do leave a like and share it with others. Subscribe to my channel for further updates, not just on large language models. As I have shown here, I cover various open source libraries around Python, and I discuss a lot about how to learn these libraries and use it in your day-to-day activities at a very high speed. So that is one of the key aspects that I cover always. With that said, I would like to leave this particular video with 4 words. Yeah, I'm not going to share you the code, but still I'm going to request you to practice. See you guys. Have a great time.